In this lesson, we're going to look at some special relationships between the trig functions. These are called the reciprocal identities. Let's first, though, look at some reciprocals. In arithmetic, we learned that two numbers are reciprocals of each other if their product is 1. For example, we know that the number 3 has a reciprocal of 1/3, and if we take the number 3 and we multiply it by 1/3, then of course we think of the 3 over 1, we get 3 divided by 3, which is 1. For the number 4/5, its reciprocal is 5/4. And notice when we multiply it, we get 20/20, which is 1. And for a negative number, negative 5/7, then its reciprocal would be negative 7/5. And notice also, negative times a negative gives us a positive, and we would have 35 over 35, which is 1. So keep in mind that two numbers are reciprocals of each other if their product is 1. Now, generally, what we say is that the reciprocal of the non-zero number x is 1 over x. And on your calculator, you have reciprocal buttons. The button with the 1 over x sometimes is written like that, or sometimes the button has x to the negative 1. And what that button does is it finds the reciprocal of the number that you enter for x. Notice this definition: the reciprocal of the non-zero number x is 1 over x. Let's look at the number 0. By this definition, the reciprocal of 0 would be 1 over 0, but what's wrong with that? We know that's undefined, don't we? We know that you cannot divide by 0, that division by 0 is undefined. So for the number 0, there is no reciprocal. Now let's look at how we derive the reciprocal identities. We know that for an angle theta, if we choose a point on the terminal side of angle theta in standard position, and we choose the coordinates just to be a generic x and y, and remember that can be any point on the terminal side except of course the origin, that for the angle theta we can define the sine of theta as y divided by r, and the cosecant of theta is its reciprocal, r divided by y. Well, now we know that if we multiply reciprocals, we get 1, so we know that the sine of theta times the cosecant of theta equals 1. Now what if we take this statement and we solve this for the sine of theta? Let's divide both sides of this equation by the cosecant of theta, and you can see that what we get is that the sine of theta equals 1 over the cosecant of theta. And if we had taken that same statement, sine theta times cosecant theta equals 1, and if we divide both sides of that equation by the sine of theta, then the relationship that we get is the cosecant of theta equals 1 over the sine of theta. So here are the reciprocal relationships for the sine and the cosecant. the sine of theta equals 1 over the cosecant of theta. The cosecant of theta equals 1 over the sine of theta. And the sine of theta times the cosecant of theta equals 1. Now this time, we won't go through this whole process, but let's remember that the cosine of theta equals x divided by r, and the secant of theta equals r divided by x. And since they are reciprocals, we know if we multiply them, we will get 1. Consequently, and here is that statement, cosine theta times secant theta equals 1. We could take this statement and we could divide both sides by the secant of theta, and we would have the identity cosine theta equals 1 over secant theta. Or if we take this statement and divide both sides of the equation by cosine theta, we get secant theta equals 1 over cosine theta. So those are the three identities that we need to know for the cosine and the secant. The last relationship we'll look at would be the tangent and the cotangent. We know the tangent is y divided by x, and the cotangent is x divided by y. Consequently, since those are reciprocals, if we multiply the tangent of theta times the cotangent of theta, we get 1. And here's that relationship written. Now, if we take this equation and divide both sides by cotangent theta, we find that the tangent of theta equals 1 over the cotangent of theta. And if we take this equation and divide both sides by the tangent of theta, we find that the cotangent of theta equals 1 over the tangent of theta. Copy these down. You will need to know all 9 of these identities backwards and forwards and inside out. I'd like to call your attention to something concerning these reciprocal identities. These identities are defined for all meaningful values of the variable. And what we mean by that is that they would not be defined if any of these denominators were equal to 0. So any value of theta where the sine of theta was equal to 0 in this case would not be considered a meaningful value, and this would not be defined. And that would be true for all of these. Anything that makes those denominators 0, these identities would not be defined for. Now, let's work some problems that require us to know these reciprocal identities. The instructions say use the appropriate reciprocal identity to find each function value, and the first problem we have says cosecant of theta, and that's what we're supposed to find, the cosecant of theta, and we know that the sine of theta is 2/3. Well, there's a short way and a long way. I'll start off the long way. I know that the cosecant of theta equals 1 divided by the sine of theta. In this case, that would be 1 divided by 2/3. And I know that 1 divided by 2/3 is 1 times the reciprocal of 2/3. Because when we divide, we multiply by the reciprocal. And 1 times 3/2 is 3/2. So the cosecant of theta equals 3/2. I would hope on a problem like this that you would simply look at it. You would know that these are reciprocals and know that if the sine of theta is 2/3, then the cosecant of theta would equal the reciprocal of 2/3, which of course is 3/2. On the second one, we're supposed to find the cosine of alpha, and we're given the secant of alpha equals the square root of 3. Once again, because these are reciprocals, I would hope that to find the cosine of alpha, you would simply say, well, I know that's a reciprocal of the square root of 3, and I find the reciprocal of the square root of 3 by saying 1 divided by the square root of 3. Now, we don't want to leave it like that. We do want to rationalize it. We want to get that radical out of the denominator. So we'll multiply by the square root of 3 over the square root of 3. 1 times the square root of 3 gives us the square root of 3. And the square root of 3 times the square root of 3 is 3. So the cosine of alpha equals the square root of 3 over 3. For problem 3, we have the tangent of theta that we're trying to find. We're given that the cotangent of theta equals negative square root of 5 over 7. Because these are reciprocals of each other, we know that the tangent will equal to the reciprocal of negative square root of 5 over 7. Now remember that the reciprocal of a negative number is negative. So the tangent of theta will equal to a negative, and we'll use the reciprocal of the square root of 5 over 7, and that would be 7 over the square root of 5. Once again, we need to rationalize. We'll get a negative in the numerator, 7 times the square root of 5. In the denominator, the square root of 5 times the square root of 5 is 5. So the tangent of theta equals negative 7 times the square root of 5 over 5. For this fourth problem, I'm going to use my calculator. The sine of omega is what I'm trying to find. I'm given that the cosecant of omega equals 2 and 165 thousandths. Well, my thought here is that since they're reciprocals, the sine of omega equals 1 over 2.165. But I'm going to use my calculator and use my reciprocal button to find what 1 divided by 2.165 is. Of course, I could divide it out the long way, but that's why you have a reciprocal button. So I would enter in my calculator the number 2.165, and then on my calculator, the button is the 1 over x button, and it is a first function button. For some calculators, this is x to the negative 1, and for some calculators, it is the second function button. So when I enter 2 and 165 thousandths, and then I hit my reciprocal button, that will give me the reciprocal of this, which is what 1 divided by 2.165 equals. And I'm going to round this to 4 significant digits. Since I'm going to round, let's do approximately here. And what I get is 461, and actually this next digit is an 8, but because the next digit is a 9, when I round, I get 0.4619. So the sine of omega approximately equals 4,619 10,000ths. Let's look at 2 more problems. The instructions say find a value of the variable. Well, here's the thought. If I have the secant of 4 beta minus 5 degrees equals 1 over the cosine of 6 beta minus 9 degrees, I know that 1 over the cosine of 6 beta minus 9 degrees equals the secant of 6 beta minus 9 degrees. So I'll rewrite the right side of this equation. I'll keep the left side as it is, but on the right side, 1 over the cosine of 6 beta minus 9 degrees equals the secant of 6 beta minus 9 degrees. And I know if I have the secant of 4 beta minus 5 degrees, that it'll equal the secant of 6 beta minus 9 degrees. Therefore, these two angles can be equal. So 4 beta minus 5 degrees equals 6 beta minus 9 degrees. And I will solve for beta by subtracting 4 beta from both sides of the equation and by adding 9 degrees to both sides of the equation. Those add to 0. Minus 5 plus 9 gives me 4 degrees. 6 beta subtract 4 beta gives me 2 beta. And those add to 0. So I know that 4 degrees equals 2 beta. Let's divide both sides by 2. And sure enough, we get that beta equals 2 degrees. So we found that our variable beta is 2 degrees. On this last problem, we have the tangent of 3 theta plus 2 degrees times the cotangent of 2 theta plus 7 degrees equals 1. Well, what I'm going to do here is divide both sides of this equation by the cotangent of 2 theta plus 7 degrees Those will divide out. The next thing that I am going to do here is to rewrite the right side. 1 over the cotangent of 2 theta plus 7 degrees. I know that 1 over the cotangent of 2 theta plus 7 degrees equals the tangent of 2 theta plus 7 degrees. And I know that if I have the tangent of 3 theta plus 2 degrees equals the tangent of 2 theta plus 7 degrees, for that to be possible, I know that 3 theta plus 2 degrees can equal 2 theta plus 7 degrees. So solving this equation, I'll subtract 2 theta from both sides. I'll subtract 2 degrees from both sides. 3 theta subtract 2 theta will give me theta. 2 degrees minus 2 degrees adds to 0 equals 2 theta minus 2 theta adds to 0, and 7 degrees minus 2 degrees gives me 5 degrees. So my theta in this case is 5 degrees. That completes the reciprocal lesson. Please rerun the tape if you're finished with it. Thank you.